Part 1. The wake-up call, the brain in a jar. Imagine, for a moment, that you are the smartest entity in the universe. You have read every single book in the Library of Congress. You have memorized every line of code on GitHub. You know the history of every civilization. But there is a catch. You are locked inside a dark room. This room has no windows. It has no doors. It has no cameras. You have no eyes. You have no ears. You are, effectively, a brain in a jar. The only way you can interact with the outside world is through a tiny slot in the wall. Once in a while, a piece of paper slides through that slot with some text on it. You read the text, you process it, you write an answer, and you slide the paper back out. That has been the reality of artificial intelligence for the last 50 years. That is exactly what a large language model is. It is a text processing engine trapped in a dark server. We have spent the last 2 years obsessed with text. We have mastered prompt engineering. We have built chatbots. But here is the brutal truth about the real world. The real world is not made of text. The real world is messy. It is visual, it is auditory, it is kinetic. The stock market is not just a spreadsheet, it is a visual chart with patterns. A website is not just HTML code, it is a visual interface with colors and buttons. A broken machine engine is not a user manual. It is a weird grinding sound and a flashing red light. If you want to build an AI that can truly do work, an AI that can replace human labor in the real economy, it cannot just read, it must see, it must hear, and it must act. If your AI is blind, it is useless for 50% of the jobs in the world. Today, we are breaking the glass of that dark room. We are moving from text-based agents to multimodal autonomous agents. We are going to give your AI a pair of eyes. We are going to discuss the engineering architecture of vision agents. We are going to explore how tools like GPT-4o and Claude 3.5 are fundamentally changing the engineering landscape. And we are going to look at the powerful new concept of computer use, where the agent takes control of your mouse to do your job for you. My name is Your Name from Digital ASEAN, and today we are building the AI of tomorrow. Part 2, Disclaimer and Transparency. But before we dive into the architecture, a quick transparency note. This video is created using 100% artificial intelligence. The voice you are hearing is a neural clone. The face you are seeing is an avatar generated by Jog AI. We do this to prove a specific point in the era of generative AI. Production value has become cheap. Anyone can make a cinematic video, but insight, experience, and engineering, those are still expensive. You are not watching this video for the cinematic lighting. You are here for the blueprint. We are a bootstrap research lab. We focus on value over vanity. If you are looking for entertainment, this is not the channel for you. But if you are looking for a roadmap that will survive 2026, then stay with me. Part 3, the evolution, native multimodality. So, what exactly is multimodal? It sounds like a corporate buzzword, but it is a fundamental shift in computing architecture. To understand the future, we have to look at the past. In the old days of AI, and by old days I mean 3 years ago, we had specialist models. If you wanted a computer to see an image, you used a computer vision model. It could identify this is a cat. That's it. It didn't know a poem about cats. It just knew pixels. If you wanted to transcribe audio, you used a speech-to-text model. They were separate brains, living in separate silos. Connecting them was a nightmare. You had to stitch them together with complex code. It was slow, and context was lost in translation. A multimodal large language model, like GPT-4o, is different. It is natively multimodal. It wasn't just trained on textbooks. It was trained on the entire internet. It watched millions of YouTube videos. It looked at billions of Instagram photos. It listened to thousands of podcasts. It understands that the word apple is deeply linked to the visual image of a red fruit, and the sound of a crunch, and the logo of a technology company. It connects these modalities in a high-dimensional vector space. Why does this matter for you? Because it unlocks context. Let's say you are building an agent for customer support. A text-only agent is often helpless. Imagine a customer sends a photo of a broken chair and says, "This part snapped." A text agent would say, "Please describe the part." The customer says, "The thingy at the bottom." And the agent says, "I do not understand it." It is frustrating. A multimodal agent, you show it the photo, it sees the fracture, it matches the visual pattern to its database of parts. It identifies that is the hydraulic cylinder base. It diagnoses the problem instantly. It orders the replacement part. Multimodality is the bridge between the digital brain and the physical world. Part 4, the architecture of vision. Now, let's put on our engineering hats. How do we actually build this? How do we give an agent sight? We don't just glue a camera to a chatbot. We need to understand the architecture of vision encoders. When you upload an image to an agent, let's say a chart of Tesla's stock price, the computer doesn't see a chart. Here is the process. First, the model takes that image and slices it up. Imagine cutting a photo into a grid of tiny squares, like a puzzle. These are called patches. Each patch is analyzed. The AI looks at the pixels in that square. It converts those pixels into a long string of numbers. We call this embeddings or tokens. This is the magic moment, just like the word hello is a token. The top left corner of the image becomes a token. These image tokens are fed into the massive transformer model, right alongside your text tokens. So your prompt actually looks like this: image token 1, image token 2, followed by the text, analyze this chart, followed by image token n. The AI processes the visual information and the textual instruction simultaneously. It creates relationships between the pixels and the words. This allows us to build powerful vision tools in frameworks like Crew AI. In our previous video, we built a researcher agent that searches Google. Now, imagine a design auditor agent. Its goal, check if our website matches the brand guidelines. Its tool, a screenshot tool. The workflow is elegant. The agent navigates to your URL. It takes a high-resolution screenshot. It passes that screenshot to the vision model. The prompt is now, look at this image. Are the buttons the correct shade of blue? Is the logo aligned to the left? The agent compares the hex codes of the colors in the image against your brand guidelines. It reports back, a violation detected. The button on the landing page is the wrong shade of blue. It is 6 FF. It should be 5 FF. Try doing that with a text-only model. You can't. You would have to inspect the HTML code, which doesn't tell you how the site actually looks to a human. Vision allows the agent to experience the interface exactly like a human user does. Part 5, Use Case 1, the Financial Analyst. Let's look at a concrete use case where this technology makes real money. Financial analysis. For decades, trading bots relied on structured data. They read spreadsheets, they read CSV files, but the market is driven by unstructured data. The market is driven by news clips, by CEO interviews, and most importantly, by technical charts. A price chart is a visual story. It has patterns, head and shoulders, double bottoms, bull flags. A text model cannot see a double bottom. It just sees a list of numbers, but a multimodal agent can. Here is the workflow for an autonomous hedge fund. Step 1. The Data Scout agent captures screenshots of the S&P 500 chart across 3 different time frames: daily, weekly, hourly. Step 2. The Vision Analyst agent analyzes the screenshots. It doesn't look at the numbers. It looks at the geometry. It identifies the visual pattern. I see a consolidation wedge forming on the hourly chart. It draws trend lines mentally. Step 3. It passes this visual insight to the news agent. The news agent says, visually, the chart looks bullish, but textually, the Fed meeting minutes are bearish. Step 4. The decision agent weighs the conflict. It synthesizes the visual data with the text data, and it executes a trade. This is holistic intelligence. It is using both hemispheres of the brain, the logical text side and the spatial visual side. Hedge funds are already doing this. Now, with tools like Crew AI, you can build this logic in your bedroom. Part 6. Use Case 2, the Computer Use Paradigm. Now, we arrive at the most exciting and frankly the most terrifying development of 2025. It is called computer use. This concept was popularized recently by Anthropic with their Claude 3.5 model. Up until now, agents access tools via APIs. If you wanted your agent to send a message on Slack, you needed the Slack API key. If you wanted it to book a flight, you needed the airline API. This is great for developers, but it is terrible for everyone else because most software does not have an API. What if you use a legacy accounting software from 1990? What if you use a messy web portal for your suppliers? This is where computer use comes in. The agent doesn't ask for permission. It doesn't look for an API. It simply looks at your screen. It takes a screenshot. It analyzes the pixels. It identifies that bundle of pixels in the corner looks like a submit button. It identifies that rectangular box looks like a name field. And then it controls a virtual mouse. It moves the cursor to coordinates X, Y. It clicks, it types, it scrolls. This changes everything. It means any software that a human can use, an agent can use. You don't need to wait for developers to build integrations. You can simply tell the agent, go to this website, log in with these credentials, click on the third tab, download the PDF invoices, and email them to Bob. And the agent sees the website. It sees the login box. This is the ultimate form of vision. It is vision converted into action. It turns the entire graphical user interface into an API. Imagine the implications for office automation, data entry, QA testing, customer support, ticket routing. The barrier to entry for automation has just evaporated. You don't need code anymore. You just need to show the agent what to do. Part 7, the limitations and safety guardrails. Of course, we must speak about the limitations. We are not at AGI yet. Vision agents are expensive. Processing images takes significantly more tokens than processing text. It costs more money. It takes more computing power. Latency is also an issue. If you are building a real-time robot, waiting 3 seconds for GPT-4o to analyze a frame is too slow. Accuracy is also a challenge. Hallucination happens in vision too. The model might see a shadow and think it is a cat. It might see a delete button and think it is a save button. In the computer use paradigm, this is dangerous. Imagine an agent trying to clean up your files, but it clicks the wrong button because the icon looks similar and it deletes your entire hard drive. Or imagine an agent analyzing a medical x-ray and missing a tumor because of a pixel artifact. We need guardrails. We need human in the loop. You should never, ever give a vision agent full autonomy over your bank account or your critical systems without a review step. Not yet. We are in the teenager phase of this technology. It is powerful, but it is reckless.
So treat it like an intern. Review its work, Part 8, the 2026 Roadmap and Conclusion.
So, where are we going? What does the roadmap look like for 2026? We are moving towards native multimodality. Right now, we are still stitching things together. We take a screenshot, we send it to the model. In the future, the video modality will become dominant. Agents won't just look at static screenshots. They will watch live video streams. They will sit in your Zoom meetings, not just listening to audio, but watching your body language. They will analyze micro expressions. The client said yes, but his arms were crossed and he looked away. He is hesitating. An agent that understands nonverbal cues, that understands emotion through vision. That is the next frontier. So, what should you do today? If you are a developer or just a solopreneur building systems, stop building text-only pipelines. They are obsolete. Start experimenting with vision. Go to your Crew AI scripts, add the vision tool, give your researcher a camera, ask it to analyze your competitor's landing page visual hierarchy, not just their text copy. Ask it to look at your Instagram feed and tell you why certain photos perform better. The world is visual. Your intelligence should be too. We have come a long way from the brain in a jar. We have broken the glass. We have opened the eyes. Now it is up to you to show it the world. My name is Medro Karim from Digital ASEAN. The future is bright. And now your AI can finally see it. Signing out.